Welcome back to this introduction to Matlab. In this session we'll be going from typing data into Matlab, just like it's a calculator, and then slowly moving towards reading in our data from text files. So just to remind us of our problem, we're given a data file that contains latitude and longitude, and it's in degrees and minutes instead of in decimal degrees, and we'd like to be able to read it in and plot it in Matlab. And there's a thank you to the AAD, UTAS and RV and colleagues on the BroQuest voyage. Thank you for access to your data. So here's the full file, and I've taken out all of the header information. And this is the simplest way to read data in from a text file into Matlab. And you can see that everywhere there I didn't know a value, I've entered in a dummy variable. So -999 means missing data. So now in Matlab, we'll just do the first value by hand. So I'm going to start not with numbers like in calculator. I'm going to give each number a name, so I'm going to call it some variable name. So let's choose degrees north, minutes north, and seconds north. And that would be the data that I read from the ship's display. So if I now type whose, and that just asks Matlab to report what's currently loaded into the working memory, each of those variables has appeared. Each of them is reported as a scalar, so a 1 by 1, a single value. Each one is 8 byte and it's classed as double, which means that it has a floating point with digits either side. And I can ask for the value that I typed in to be reported back to me simply like that. So I'll do that the same for the south. And now I've got all 6 values read into the memory. So I'll type the calculation out just as we did with the calculator, except substituting the variable names for the actual values. And now I can just check that those values turned out the way I expected them to. And these 2 lines of code are ready to be automated, so I can repeat those regardless of which values I put in for each of my input variables. To read those data in from a file, I simply start off by defining my file name. So there's a trick here. If you type ls, that's a Unix or Linux command for listing what's in the current directory. You can incidentally type pwd, print working directory, to ask which directory you're in if you've closed off that working directory window. So now you can copy and paste the name of the file that you're after, and I'm after this one that has no header information on it, and just with copy and paste I can substitute that in there and minimize my typing. Now the load command, if we just type help space load, and MATLAB help is very helpful. If you just remember that the very first thing each help call will tell you is how to use the function. So it says that we can assign everything that we load from this file into a single variable on the left hand side. And we could get a bit more specific, but in this case we just want to load everything in. So we'll say our instrument data is equal to load and then the file name. And by using the file name as a variable, that means that we're ready to automate this also by asking for a directory listing and then substituting in successive file names. So if now I ask what's in my working directory, we can see that my ACS data is 232 rows by 17 columns. So now everything depends on me knowing which of these columns corresponds to which variable. So from this point it seems sensible to me to start working from a script. So I start a new script. And now I can type all of these commands in and save them as a text file which is portable. So I can make a note of which column was which. Column 6 is latitude degrees. Column 7. And now I can extract each column from the ACS data from that big array. So the syntax here is to extract all of a single dimension is a colon, and I'd like column 6 for those latitude degrees, and I'd like all of column 7 for the latitude minutes, and all of column 8 for the latitude seconds. And similarly for the longitude. So that's all our variables loaded and also extracted just to make things a little bit simpler. So now we type the formula for converting to decimal degrees using the appropriate variable names. I've been very overcautious with the brackets here to make sure that everything is divided the right number of times. And then just as this formula worked, or the similar formula worked for a single variable down here, it will work also for these columns of data. So we can paste that all to the screen now, and off it goes, and we can double check with whose that our new decimal degrees have 232 rows and 1 column, as expected. So we just processed all of our data in one go, and now we can plot it. For one or two variables, it's useful just to use a command that's called plot, very friendly. We'll put longitude on the x-axis and latitude on the y-axis. We'll remember that our latitudes are in the southern hemisphere, but they're all positive, so I'll add a negative there. And then I'll just choose a colour, green, and a symbol, S for square. And if I just paste that into the command window, my plot window appears. So now we see there are the negative values that meant that we didn't know where we are. And here is our cruise track with stations coming down onto the shelf. So great, we've started loading data into Matlab. We've used the very straightforward load function. We might want next to look at something a little bit more sophisticated, which is called the text read function. And then we can start analysing and plotting our data.